I would like to start by saying good morning to you all, and welcome to our webinar, Going Circular, EU Innovation Projects for a New Economy. Today, I will be moderating on behalf of our host, ISWA, the International Solid Waste Association. My name is Jose Uribe, and I am the Operations Director at ISWA, and also an EU project manager in my spare time. We all need a hobby after all. Today, we have gathered 8 EU-funded projects for you that address a variety of issues and innovations for greater circularity. You can see them in the agenda in front of you. Some target specific industries, like the automotive industry or textiles or flooring, while others focus more on specific technologies, such as material separations and the removal of legacy contaminants. Today, they will each present their own project, after which there will be time for to answer some questions. So if you do have any questions during the presentations, please write them into the chat. We will make sure that they get a chance to answer them. After we have gone through all the presentations, there will be a chance to have a short but hopefully insightful roundtable discussion where we can address some of the more systemic challenges faced by all the projects have in common. But before we get into all of this, I would appreciate if we could take just a couple of minutes to tell you about ISWA and why we're here today. So ISWA, the International Solid Waste Association, is an association representing waste management stakeholders across the globe, and with a mission to promote sustainable and professional waste management around the globe, as well as a transition to a circular economy. So that is what
Jose, we lost you for a little bit. I think you're muted. Can you?
Yeah, you're on mute.
Oh, I am so sorry. I don't know where you lost me, but I will start again. The International Solid Waste Station, as I said, represents a full range of waste management stakeholders with a mission to promote safe and sustainable waste management across the globe and a transition to a circular economy. One of the things that we are witnessing right now from within the industry is a shift in focus, where we see the change in approach from the managing of safely managing waste streams to more an approach of recirculating resource and valuable streams. But we cannot do this alone. To be able to do this effectively, we must redesign products and materials so that they can take advantage of the new concepts and ideas we have about how to reuse and recycle those products. In this regard, ISWA believes that to be a product design that does not include the end of life stage is just simply not complete. So what does this mean? This means that to do this evolution from a linear to a circular economy, we must also have a greater engagement between the end of life stage and the beginning of life stage, i.e. the manufacturing and design stage. So as a matter of fact, ISWA proposes that we should not only circulate materials, but also knowledge back into the chain. As a knowledge and networking hub, ISWA already regularly addresses end-of-life issues that include reverse logistics, reuse, materials, separation, and recycling. So from a practical perspective, we are well positioned to participate in circularity projects, mainly, of course, as a communications and disseminations partner. However, from a strategic perspective, ISWA engages in these projects in a bid to better connect with other life cycle stakeholders so that together we may redesign value chains for greater circularity. I think at this stage, I would also like to acknowledge and thank the European Commission, without whose generous funding both these projects and this event could not be taking place. one of the things, of course, that I always hear from the European Commission is the fact that they would like to encourage better and broader collaboration between EU projects. And that is one of the reasons, of course, that we are here today, and we honor their wish. So, of course, I would like to point out that we're not here to listen to me today. So I would like to just go on and introduce you to our first speaker, who will be Guy Beyle, will be presenting to you about his project CisuFlo, about sustainable and circular flooring. So Guy, over to you.
Thank you. I hope you can all see the right screen, or it's switched again.
Switched again.
Sorry. Okay, good morning all. And it's really a pleasure to present here to you our CisuFlo project and this interesting group of European projects. And so CisuFlo, it's about circular sustainable floor coverings. And I think the title already says it quite well. Our main goal is really to see how the circular or the flooring sector can be made more circular. And for that, we have some different elements. On the one side, we want to work on projects and make them, let's say, more fit for circular economy. And that means, in first instance, that they can be made from recycled content. But of course, you also have to create the recycled content. So that means that the products themselves should be suitable for recycling, and that we will also work on some recycling technologies in the project. Then that is the technical level, but we're very well aware that that in itself will not be sufficient. You really have to look at the whole value chain to see how things can be fit together, maybe change the business models to something more circular and so on. So that's the third element. And then it's, let's say, the assumption of the project that even if we do this well, then we will not find the solutions or the most efficient solutions only within our own sector. So that we also have to look at other sectors that are linked to it, for example, the construction sector or the furniture sector, for potential exchange of secondary raw materials, and this to optimize their use. Of course, the flooring sector is very wide, contains a lot of different products. So the challenge was, because we want to do a systemic approach here, to, on the one side, remain sufficiently focused, but on the other side, to be really representative for the whole sector. And in order to do that, we selected three different product types. It's first of all the laminates. So let's say the floor coverings that contain sufficient amount of wood, wood-based. Then the resilient flooring or vinyl flooring, where a key material is PVC. And then also the textiles, typically the carpets, where the main materials and counters are polyamide and polypropylene. And so with these groups, we try to really have a good, let's say, cross-section, a good representation of the various products that are present in the flooring industry. And what we do not cover is anything ceramic, so like the typical tiles. If we then look at the key objectives of the project, well, then it comes back to these elements that we had in the beginning. We see, of course, we have some technical challenges, but definitely also on the level of the more wider, let's say, the socioeconomic context, and also on some digital elements that we would work on. And so first of all, we will work on the design for circularity, eco-design, and make some prototypes of floor products that are truly circular. Then another key objective is the development of the so-called e-produce system. And so that's basically a product information system that has as goal to ensure everybody along the value chain, the circular value chain, has access to key elements of the product. For example, at the moment of recycling, that the recycler can look for some info on how to deal with the product, if there are potential additives in the product, and so on. Then we also have the parts on the value chain mapping to understand what could be potential material streams, how they can link to other sectors. We have as one of the objectives, the implementation of 6 pilots, and more on that in the next slide. And then I would say, here's a European project. So we have also some typical other key objectives, like the sustainability assessment of the new technology. we would anyhow do that. And all the way on the right about the dissemination, raising awareness. One of the things why we're thankful with an event like this. And then, as mentioned, we also have the part on the circular business models and the collaboration cross-sectoral to see for potential synergies. As mentioned, one of the key objectives is the implementation of 6 different pilots, and they're listed here. We don't have to go in detail about them, but just to give you a short intro on what we will do. So on the one side, we will produce what is called circular floor coverings. So that is these prototypes of materials for laminates, for carpets, for resilient flooring. That can be easy recycled, that take into account the different aspects from eco-design and so on. Then we have one pilot that specifically looks at the identification of the products at the end of life and at the linked sorting. We have one pilot that looks more at the separation process for some of the more complex products, like for example, carpets. And for that, we will use a patented technology, the so-called Polycep technology, and use that on some different waste materials. Then we have one pilot specifically for the laminate flooring recycling, where the goal is to take end-of-life laminate and see if it can be processed again into mainly the high-density fiberboards, because that is the basic component of laminate flooring. We have one pilot on the vinyl flooring, and there the goal is to see if we can link it to the construction sector and use PVC waste from that sector and take it into flooring products. And then the last pilot is actually the most extensive one. It's about carpets. And there we want to show the whole life cycle of the product. That means that we will do this prototyping of the material, then install it, simulate the use phase, at the end deinstall it, and do the actual recycling into new secondary raw materials. So that's about the pilots. Of course, with all these key objectives with the pilots, we hope to have quite some results. I will not go into detail here because it's, let's say, at this moment, since we didn't start so long ago yet, it's a rephrasing of the key objectives and what is expected there as results. I think what is important to mention already is where we want to end, because with these results, what we would like to help to establish is a systemic framework for having a circular and sustainable floor covering sector. So let's say the non-technical part. Then on the other hand, we want to really help to shift the material use from the linear use as it is now to a circular materials flow. And by doing that, of course, the main goal, the main impact expected is that we can help to minimize the total environmental impact of the flooring sector in Europe. Where are we? I said we didn't start that long ago. We're now in month 10. And just to give you a hint of what is being done, what is being worked on. In the beginning of the project, of course, we have a lot of emphasis on these prototyping according to the Design for Circularity rules. Aspects or activities ongoing there is the focus on producing carpets that are or made from a monomaterial, so that they're easy to recycle, or if they have different materials, that they're easy to separate, so that again, recycling becomes more easy to do. When it comes to the resilient flooring, there's quite some tests are run at the moment on lab scale to see what kind of secondary raw materials can be used, meaning from what origin, and also up to what percentages they can be added to the product with, let's say, current manufacturing processes and current manufacturing technology. And then we also have in that part a specific focus on what is called biocomposite flooring. So in that sense, it's more a new type of flooring that will be made from natural fibers, natural materials, and combined with only recycled materials. Another important part that's being worked on at the start, since the start, is this product information system. So as mentioned, the goal is to set up quite a basic system because the goal is to have it widely accepted by the whole sector, but that still offers in a trusted way to make the information available to the different players in the value chain. And what we are following there is the route to try to link that to the concept of the digital product passport, which will anyhow, let's say, appear. So we would like to, from sector viewpoint, to make the best of that digital product passport. And on the other hand, important is also that this product information system will also have an entry for consumers, with the idea that you can get info, for example, at the moment you will buy the product or the moment you have to maintain the product. And that, of course, with the idea that that way consumers can be stimulated to maybe purchase and also maintain the product in a more durable, in a more sustainable way. And also already ongoing is the preparations for the first pilot lines. The picture there shown on the right is about the sorting and separation line, but also the laminate recycling pilot line is already being built and first tests are going on. That was it basically from my side. Of course, all this work cannot be done by one single partner. It's the effort of a lot of partners. So I would like to thank all the partners in the consortium. You can see them here. I think we have a quite well-varied consortium. And I would also really like to acknowledge the EC support that we got for the project and all of you for listening. Thank you.
Thank you, Guy. That's an interesting presentation for sure. One of the things that I was wondering while listening to it, and also from previous experience in other projects, is of course the fact that when you have to deal with materials coming back in, you don't know where they've been, and I can specifically see that in flooring, that there's maybe a lot of contamination and a lot of uncertainty as to what exactly you're getting back in, not just in the material that was originally used, but also in contaminants or what they've been through. Is there some sort of way that your strategy that you're using to be able to compensate for that when you're trying to reuse these materials?
On longer term, I think there is the vision that with this product information system, even if it comes from different sources, at least one should know something about the material, how it was made, what was put in it, up to a certain extent, because of course, some of these things can also be quite confidential info. But that is, of course, for products that will enter, let's say, the end of life in some years, because that's not in place. If I look at it for the moment practically, then I think the approach being followed is actually that the fractions of recycled matter is still quite small. So the basic approach is that if one adds a certain fraction of the recycled matter, it hopefully doesn't have too strong influence on the process. So you can deal with some variability there. You can deal with, let's say, some uncertainty. And I think that's for the moment how it is, how it's pursued in practice. But on longer term, as I said, the vision is to have a better view on what comes in thanks to these information systems, and also thanks to some good sorting systems, which will also have some detection of, let's say, no-go substances.
Okay. Thank you for that. We have to move on now to our next project, which is ALMA, Advanced Light Materials and Processes for Electric Vehicles. And for that, today we have Rajesh Mehta from TNO presenting. Rajesh?
Thanks, Joshi. Good morning, everyone. And I'll be presenting the ALMA project and the PEFSIM tool we developed in this project, which is a sustainability assessment tool for lifecycle assessment, lifecycle costing, and circularity assessment for passenger vehicles, especially for the battery electric vehicle. And ALMA stands for Advanced Light Materials and Processes for Eco-Design of Electric Vehicles. And in this project, we aim to design, validate, and build a lightweight prototype of battery electric vehicles. The scope includes body in white and closures. ALMA aims to have a modular platform and subsystem design that falls in the acceptable range for functional safety and manufacturing requirements of the OEM's standard operating procedures. We plan to have a design, validation, and build-up of a physical demonstrator using the ALMA developed lightweight materials. It's a joint collaborative effort among 9 partners, industrial and non-industrial, which is pivoted, I would say, by CTEC and Ford. CTEC is the project coordinator here, and other partners are lead in specific work packages. It's an EU-funded program which runs for 3 years. We have a 2.5 million total project funding, and the main focus is to drive the TRL level 6 technologies all the way to TRL level 8. The ALMA concept and innovations actually start from the eco-design of the vehicle structure, which is supported by LC and LCC. Ford, CTEC, and TNO are lead here. The main emphasis is on setting the functionality right and making sure that the requirements for the eco-design of the vehicle is really taken into consideration holistically, including a sustainability assessment. There are several innovations which we are going to do or we are developing in ALMA, right from developing advanced steel products all the way to sheet metal composites, which could go into making the vehicle later. We are also looking into efficient separation and recycling and recovery of materials at the vehicle end of life, so that the circularity performance of materials beyond metals are really enhanced. And that's where the big challenge lies in automotive end of life management. Beyond that, we are also making sure that the vehicle reliability and lifetime is enhanced through structural health inspections and tools which could actually increase in the overall reliability of the vehicles. Finally, the entire emphasis is, as I said, validation of the ALMA prototype at TRL level 8. And in this project, one of the work packages was to develop a sustainability assessment tool specifically designed for the automotive industry. TNO developed a single tool which can cater to the LC assessments, life cycle assessment, for those who don't know, which is environmental assessments for different products or processes or technologies. The tool is able to actually do all three, LCA, LCC, and circularity assessment within a single platform. It's a web-based tool hosted on TNO's web Diamond platform, which has an inbuilt database for lifecycle impacts. We have best-in-class LCM models for material production all the way to end of life. Different comparisons are possible. You could compare a battery electric vehicle versus an ICE vehicle for segment C and D cars, and we are planning to enhance it for commercial vehicles as well. The tool has been designed to be customizable, where a user could model a full car, a subsystem, or a part of a car here for all the three types of analysis. And it is also possible to include customer or user specific data sets here. The tool's main functionality is also to enable version control so that you could update the LCA data sets rather easily compared to complex Excel-based tools. The overall design principle for ALMA for this BEFSIM tool is to compare design alternatives by known LCA experts who are really not experts in LCA methodologies and make it simplified for the users here. The entire effort is to also take into consideration future scenarios for 2030 and 2050, hard-coded in the tool so that design alternatives are really evaluated early in the design cycle to prevent any wrong choices being selected, especially at the end of life management or recyclability options here. The tool really enables faster LCA evaluation during the early product development stage. Now the BEFSIM capabilities, if I have to talk about, the tool helps measure lightweighting solutions, design alternatives, as I said. It could be at a subsystem level, or it could be at a part level. Material choice impacts on the overall sustainability performance and the economic performance of the material choices is there. The use phase impact coming in from the choice of the vehicle geography or other elements are possible to compare. The most important element, which I would say in the tool, is the recyclability aspect or the recycling technologies, which we have captured holistically for different materials going into an automotive car. The end of life options, which are traditional, and how do you move away from them to recycling is a key element which can be compared. The tool has been designed with an interactive user interface, which is rich and allows product designers, engineers, and known sustainability experts and business owners to iteratively see the design options and compare designs at a car or subsystem or part level. And of course, you can see the LCA impacts which are in line with the ISO principles of doing a full LCA for an automotive vehicle. What we have done in this entire assessment is we have taken away the complexity of making the harmonized LCA technologies or methodologies and build in the tool itself, so that a sector specific simplified tool is offered to the known sustainability professionals, so that they can make the right choices in the product design cycle or during their day-to-day business decision making. And circularity impact assessment is also an important criteria which the tool offers as a evaluation option there. Now, what will this project, ALMA, change in the future economy? At ALMA, we are designing the future of e-mobility through new and sustainable innovation solutions by leading to lighter multi-material electric vehicle body. Through the ALMA design, we are also ensuring reliability and structural integrity and longer service life through the ALMA's work package development. ALMA project is going to accelerate adoption of circular economy principles across the entire automotive value chain. That's our wish and of course ambition to have. And of course, it also depends on how fast the industry really picks up the ALMA solutions and absorbs it into their business as usual scenario. One of the key objectives for ALMA is also to have affordable solutions for the market for lightweighting, and to have a wider acceptance of such novel solutions for the automotive industry. What is upcoming in the tool is advanced light materials fine-tuned and produced by ALMA project. And of course, we are going to do a full LCA and LCC components study for the ALMA solutions compared to the reference design. And the evaluation of solutions for recycling and recovery is also, which is upcoming in the project. To sum up, I would say stay tuned for the upcoming developments being announced by ALMA project. And if you would like to know more about the ALMA solutions or technologies, feel free to reach out to me or ALMA partners directly. And thank you very much for listening in. And I would be pleased to take on any questions here.
Hi, thank you very much, Rajesh. That was a very interesting a presentation. One of the things that I know also from other projects is that when we look at particularly complex materials, that the value inherent in those materials, of course, makes it not so much of, it makes it a bit of a waste, really, to go to recycling as the first step, or at least you should always try to re-examine reuse scenarios. I was wondering how you plan to tackle that in a difficult area like automotive industry, where there are so many regulations and difficulties in trying to be able to reuse components that you might not know the exact condition of when you're trying to reuse them, or how you can approach that idea of trying to reuse materials or components at the highest value level possible.
That's a very good one. In fact, so what we are looking into is how do you actually make sure that the vehicle life is enhanced? That's the first part, through on-board sensor development from ALMA technologies. The other element is efficient sorting and separation of the valuable components for reuse and tagging them for the value chain, which is, of course, in this case, it would be ALMA, it would be automotive value chain to preserve value. And if I have to throw you some numbers on the circularity of the automotive value chain, beyond metals, other materials, the circularity is less than 10% as of now. So that's really a pity, especially when you have more than 180 kgs of plastic components going into a car, which forms probably 20% of the overall car value. And these are like high-end thermoplastics which go in, and they should not be going for incineration or downcycling options. They have to come back to the automotive value chain. And that's where the recycling options are getting evaluated. And I must admit, it won't be easy as well, because these are multi-material products, and to separate them out, the sorting technologies, today we don't have that as efficient as we would like to have them.
Yes.
So it's
Well,
definitely a challenge for ALMA and beyond ALMA, I would say, for the industry.
luckily, you still have some years to try to figure that one out. So
Yes.
thank you very much for your presentation. We will now be moving on to our next presentation on Multicycle, a project on advanced sustainable recycling processes and value chain for plastic-based multi-materials. Dr. Martin Schlimmer will be presenting from the Fraunhofer Institute.
Okay, hopefully everybody can hear me right now. And you can see the slides. Wonderful. Then let me directly step in. Multicycle is a project on advanced and sustainable recycling processes and value chains for plastic-based multi-materials. So we come back to the issue that the last presenter brought to the table. Multicycle is an innovation action. It lasted 3.5 years. It is almost finished, so we have only 2 more months to finalize one. We had a budget of 10 million, 19 partners in 10 countries. Not that important, probably. The goals of Multicycle were to really build up a recycling pilot plant for multi-layer packaging and composite materials from automotive, which is a fiber reinforced material considered here. And the plant was based on the Creosote process, the solvent-based one. I'll come to that later. And the idea was to optimize and upscale that process in an industrial environment, to integrate monitoring and supercritical CO2 extraction, not that important in this talk today. And where I would like to put a focus on is to have demonstration of recovered materials potential for reuse in packaging and automotive. So I will show you demonstrators that we have built from our waste streams. Let me start with the first one, the Multicycle material challenge from packaging. Of course, we mentioned multi-layers, but of course, most of you might know that there is no multi-layer fraction in sorting. However, there is a multi-layer waste in production. So what we used in the project was both. On one hand, we had kind of multi-layer fractions directly from film producers. And of course, the focus was also post-consumer material. And here we made use from direct sorting fractions from German recyclers in the end. Here we use the mixed polyolefin flexibles. The idea is to go back into packaging with these materials and where it's not possible to go into textiles. In automotive, we have also more or less the issue of post-industrial waste. Since here we had the issue to go for fiber reinforced materials made from PP and PA mainly, and also to recover glass fibers and carbon fibers. This is of course most easily done with post-industrial scrap. That's what we meant, but we learned that even in such part here, we have both glass fibers and carbon fibers combined. So in the end, it was very tricky to find a good input for our project. In principle, much more is possible, but with the demonstrator build, we had some limitations here. We also had a look in post-consumer material here. This was material from post-consumer cars here, fans from polyamide glass fibers. Yeah, the process that we are talking about is the Creosote one. Probably some of you have heard about. It is a solvent-based process, but it is not a chemical recycling. It is a material recycling. This is very important. It is like mechanical recycling that we always keep the polymer intact. So we don't hamper the polymer. It is only that we dissolve it and keep the polymer all the time during the process. After dissolution, we have the chance to purify better than in a melt state of a polymer. Of course, in the end, we have to recover the solvent by drying processes and get the recovered polymer. Solvents keep in a circle, and of course, purification means we have always a leftover. Leftover could be something which is not reused, In our case, we try to make use of that. So if we go with a multi-layer packaging into, we first try to get out the polyolefins, PE, then PP. Then we also had it for PA and even for PET. In the automotive sector, we had PA and PP as an input, and the residues were carbon and glass fibers. And here the recovered polymers, of course, then polyamide or polypropylene. The main outcome of the project is, of course, that we now have an upscale pilot plant for our technology. It is a Tier 7 pilot plant. It is run by our partner LEVIS in an industrial environment. It has a small nominal capacity, but it is now a good chance to have productions in the ton range for many of the projects that we were asked for. It is placed in a hall with 1,800 square meters, plant floor space is 350 square meters. Lots of piping, of course, it is an ARTEX directive plant. And as I said, it is now, after the project, available for further trials for everybody in the world who wants to go for packaging or automotive recycling trials. What was possible right now with that? So in the end, we recovered a post-consumer recycled polyethylene coming from these 323.2 flex PO waste sorting fractions. And it was possible to reintegrate that into the original ARMCO film structures, which are currently on the market, directly replacing the other PE. Here with 74.5% of PCR in a structure of OPP PE. This is, let's say, the new recyclable structures that they have. In another structure where we have the typical old one with PE, EVOH and PET on it. You see it's much more, it looks a bit more fancy. Here, of course, due to the lower amount of PE in that one, also the share of the PCR is lower. We have a bit more than 50% of PCR polypropylene in such sachets here. As a demonstrator here, we have also an OPP with metallized OPP and PP. So this one is a very good new structure for very well recyclable, despite it is in principle still a laminate. It was also possible to make use of the PA, which was left over from the multi-layer fractions. This PA was then also purified in the creosote process and was used here in these cast films with 30% in the PA fractions, and it was then recovered or used for these very nice demonstrators made from PET oriented PA and PE. And for the film experts in here, it was even possible to make a biaxial orientated cast film with 30% of post-industrial PA. Here you see the stretching behavior. It was really homogeneously stretched, possible, and yeah, the leftovers here were used for the other project up there. So wonderful outcomes in the packaging area. The PET, which was also in multi-layers, was used then by partner Cylon to produce recycled PET with quite good success. You see, one of these will not that well. Just let me recover that one. Yeah, here you see it goes down, but in the first two examples with better fractions, it were very well, very comparable to virgin. And another very nice demonstrator was to go back with the polypropylene and polyamide into laminated sheets. This is a fiber reinforced, glass fiber reinforced sheet made for the automotive industry. And this was done here by the partners Bond Laminates and Lanxess. And here we could make use of 30% of RPA and 30% of RPP. We could have gone higher than, but then there was a bit of it was a bit more tricky to adjust the parameters. So it was not because it was not possible at all. It was just 30% was possible without any change in the process. They just took the material as it is, as they virgin, and put it into, and it worked directly. Very, very nice outcome. And finally, these battery, we will now produce such battery carriers where we make use of polyamide glass fiber reinforced and polypropylene glass fiber reinforced, 2 types of that one. And also we have these L-shaped materials from Lanxess in these parts. We will also produce, are currently about to produce door panel pockets here. And here we make use of the recycled PET, which is then produced to a non-woven here. And of course, there will also be a polypropylene sheet out there from our recycled material. So it will be wonderful demonstrators in the end. Let me finally hint to our final event in Ghent on April 7. So if there are any questions on that one, just let me know. That should be everything for now. Thank you very much.
Thank you very much for that presentation. It was very interesting. We actually have a question from the audience for you. Of course, with the caveat that we understand that this is still in the pilot phase, but perhaps you could say something about what is the expected cost of this process. So once it's upscaled, of course, is it going to be market competitive, or how do you see it becoming an economically viable process?
Yeah, that's a really wonderful outcome of that the pricing at scale. So if we do the calculations for a commercial plant size, which is in the range of 5,000 to 10,000 tons a year, which is not pretty much for waste packaging, for example. The amounts available on the market are quite higher. But in that range, we come to prices that are below or very, very close to virgin. So it is exactly what we wanted to, what we aimed for. And the good news, as you saw here, it can replace virgin. So it is worth being considered. It is not double as high from the pricing. We have, with LEVIS and his mother company, a plant engineering with us, which can directly start to commercialize that technology. For the packaging area, we are, from my perspective, done with all the developments. We can go into commercialization projects. That's the very good news from that one. For the automotive, the prices are also very, very good. So no problem from that one. Here we have to reintegrate into the value chain. So into a circular value chain. So right now there is no glass fiber reinforced material sorted out from end-of-life vehicles. That's missing. And that means for now, we have to feed such a process just from industrial waste. And most partners we were in contact with had not volumes of several thousand tons per year. But of course, if some of them collect together, it might work. And then probably we just need to find a very good spot for that one. So that's, okay. That's what we're working on.
Perfect. It sounds like great news in any case.
Yeah, wonderful.
Congratulations on those results.
Yeah, thank you.
We have to move on to our next project, which is DECOAT, focusing on the recycling of coated and painted textile and plastic materials. And for that, we have Ine de Wilder from Textile presenting.
Okay, I'll share my screen. Good morning, everyone. Today I will give you a brief overview of the DECOAT project, which stands for Recycling of Coated and Painted Textile and Plastic Materials. Just some facts first. So DECOAT, as I said, a European project, which is coordinated by Textile. It's a joint effort of 17 partners, and it's a 4-year project. So as you see on the time scale, we're now in the last year of the project, but due to the COVID pandemic, we will also work a little bit in 2023. So still 1.5 years to go. Here you have an overview of our consortium. As you can see, we have a quite nice mix between end users, technology providers, research institutes, and also companies who support the project with other activities. So what is the scope? So actually coated textiles and painted plastics items are very abundant in our daily lives in various application areas. I just have a few examples here. There are much more to find, but just to give you an idea which products we are talking about. So why do these products have a coating or a paint? So these coatings or paints, they enhance the performance of the object. For example, it can protect the bulk material from UV radiation. It can give additional functionalities. For example, a coating can waterproof a fabric, or it simply improves the aesthetics of an item. But on the other hand, the presence of this coating or paints, they hamper the recycling process at end of life. So these items are nowadays either being incinerated or landfilled. So actually what we want to do is we want to recycle the bulk material by removing these coatings and paints. So this is nowadays actually a missing puzzle piece to have a fully circular approach on this. So here you can see actually the overall concept of DECOAT. What is most important to see is actually that we are aiming at a fully closed circular approach, so a closed loop. And we will demonstrate actually this closed loop for 4 use cases: a bike bag, switches and sockets, and bus and car parts. So if we go a little bit more into detail on this cycle, so first at end of life, the discarded items are being disassembled. So for example, with this backpack, we will remove the straps, the zippers, the buttons, and so on. This is not the main focus of DECOAT, but the technologies we are using can also be used as this disassembly step. So then go to a sorting step where each individual waste piece needs to be ending up in the correct debonding device. And these debonding devices are actually the core of the DECOAT project. This is the step where we will remove the coating or the paint from the bulk material. So to remove these coatings or the paints, we have 2 strategies. Either we debond via a triggerable coating. So in this case, we will need design for recycling, as we will need these triggers during the production of the materials. The second approach is solvation of the coating, and this can be done on conventional products. Of course, design for recycling can help here a little bit if you choose for more easily dissolvable coatings. So here you have a schematic overview of actually the principle of the triggerable coating. So actually between the substrate and the top coats, we have a primer or an adhesive layer where we will put specially designed triggers. During the use phase, these triggers are just there doing actually nothing, as a matter of speaking. And at the end of life, these triggers will be activated. This can be done thermally via heat or steam or via microwave. And when we trigger at that moment, they will induce the separation of the substrate and the top coat. And thus this substrate can go back to recycling. I just have here some examples. For example, here we have a PU foam with a PVC foil laminated on top. And by using a triggerable primer layer and after exposure to heat, this PVC film can be nicely removed. Another example is one on textiles. We have a PU coating on polyester. The blue is just for visibility. And here we can actually, after the heat triggering, also nicely remove the coating from the textile. And here is one example on ABS, where we actually apply a steam treatment to induce the removal of the paint. As you can see here, we have a good adhesion before and after it can be removed. Yes, we also use the Creasolve process, which was mentioned before by Martin in this project. So where we did some testing in PU, acrylic and PVC coated textile. So we used polyester and polyamide, and we have very nice results on this. In all cases, the coating could be either be dissolved, as you can see on this picture, or it can be delaminated. So we always end up with a quite clean, pure textile in the end. And for the plastics, we did testing with conventional primers and paints on ABS and on ABS-PC. And here we saw that the debonding efficiency was dependent on the type of plastic. So for one plastic to another, it needs more fine-tuning the process. So it was a little bit more difficult than the textile. If we then go one step further in the loop, so now we actually have a mix of the decoated, of the debonded coating and the bulk material, and there we will use just conventional methods to separate those two fractions. And then the bulk material will be further processed via an extrusion process, and we end up with secondary raw materials in the end. Of course, we have quite some supporting actions also. We have done quite some reprocessing studies actually to see the effects on the material properties. For example, these triggers, do they withstand the aging of the samples? Like these processes, the debonding process, don't they affect the properties of the bulk materials? How many times we can reprocess and things like that. So it's quite elaborate studies on all that. Further, we also do a life cycle costing because we want to be sure that the technologies, the additional steps we introduce in the recycling process are actually not too expensive, because when they will be too expensive, it will never be economically viable and it will never be implemented. So we need to be able to compare different technologies and also see their effect on the cost price. Further, we'd also do a life cycle analysis because we also want to make sure that the environmental footprint of these recycling processes are still okay, and we don't, they're still okay. And then last, we also do a risk assessment. There, the idea is, for example, if you put triggers for like carbon nanotube based ones, we don't want these triggers pose any risks or to human health. So we want to make sure that everything we do is still safe during use phase and afterwards. Here I have an example of the stage we are in at the process. For example, here with the switches and sockets. So the socket here, it's thermally debonded. So the coating decoats, and then we do the grinding step. We remove the coating from the bulk material. This bulk material is further being reprocessed. So this is the stage we are in for the moment. So what still needs to be done in this project is actually reprocess this regained materials again into novel sockets. But it gives an idea of how far we are in the project currently. So the acknowledgement, of course. And I would like to finish off by saying that in nature, nothing is created and nothing is destroyed, but everything is transformed. And this is actually also what we are doing in DECOAT. We are transforming current waste into novel materials. And this was a little bit, in a very nutshell, the DECOAT project. Thank you.
Thank you very much, Ine. That was an interesting presentation. I was wondering about what you said about studying the ability to recirculate the materials. And I was wondering if you could say something about what the qualities are. So once you go into the secondary raw material market, can they come back and do for several different cycles, or is it a one-time deal? How can we, have you been able to get any results on that yet?
Yes, it depends a little bit on the type of material. So, and also the process. For example, one process will influence the properties more than the other, but we can see actually that we can sometimes easily reprocess up to 5 times. So the thing is that the remaining coating, the residue, cannot be too high. So if you are able to remove most of the coatings, you can actually do quite well the recycling. What we saw is that actually the most critical step so far is actually the extrusion process in the end. So not the debonding. So then you really need to tune a little bit your process, check the purity levels, possibly blend with some virgin materials. So the full study is not completely yet, but from the debonding, we actually see we have quite nice results on that.
No, and at least 5 recirculating times, I think, is already a good start. So thank you very much for that.
You're welcome.
There is a question from the audience, apparently, Ina, before you go.
Yes.
Do you have a coating manufacturer as a partner in this project, and who is that?
A coating manufacturer as such, not. We have, for example, Meyer and Panasonic, who are actually just implementing their currently used primers and paints, which they buy from someone. We do the same. We buy, for example, from a Covestro or other companies who actually supply the standard textile binders. And then we blend in ourselves these additives that we make. And of course, we have Resco and on board who are actually producing these primerable layers. So that's their core job. They also have them already commercially available. So for that one, we really have the producer on board, but for the others, not for the moment. But it's more a matter of just the standard materials and you blend in certain additives.
Yes. Okay. Thank you very much for that.
You're welcome.
We're now moving on to our next project, which is called HereWear. And this one focuses on bio-based materials for locally manufactured circular clothing. So again, textiles. Please welcome Lien van der Scheuren, also from Textile, presenting.
Hi, good morning, everybody. And it's really my pleasure to be here today and to be able to introduce you to the HereWear project. So my name is Lien van der Scheuren. I'm working as a researcher at Textile, and together with my colleague, I'm coordinating this project. I will start with a short introduction on what we are doing and then give some updates on the work. So I would say most important to know is that we started in October 2020 and that our project will last for 4 years. So we are now about 1.5 years running and working on the HereWear project. We have a project website, so if you would want to have some more information after my talk, you can always go there and have a look. First of all, to introduce what the HereWear project is and what we want to obtain, you see here a picture of what the clothing industry is at this moment and where we would like to go in future. So on the left side, you see how clothing is still being worked on or worked with at the moment. We have the production of raw materials, for example, in the Middle East. Production of clothing is happening still a lot in Asia. And then finally, once the garments are made, they are shipped to Europe and we are using our clothing. At their end of life, we still see a lot of incineration and landfilling, which is happening, causing, for example, also these microfiber releases. So as you can imagine, not at all a sustainable way to work with our clothing. So that's why we want to change this and to move to a more sustainable way of working with our garments. This is on the one hand to make circular value change instead of the linear ones. So that's why you see all these circles on the right side of the figure. Of course, we believe that if you want to go more circular, the only way to do this is to also work locally. So that's why we have these circular hubs spread over Europe. And another aim we want to do is to get rid of the fossil-based materials and to work with bio-based materials. And also our end-of-life options are recycling and of course not going to landfilling or incineration. So as a summary, what do we want to obtain within HereWear? A more sustainable clothing industry based on 3 pillars: circularity, bio-based materials, and local manufacturing. And I'll just go a bit more in detail in each of these 3 pillars and what we are doing for these 3 pillars. So first of all, we have the circularity. Here we are creating circular design guidelines, which are really also focusing on bio-based materials. Within these, we also give some guidelines on to better use our garments and also reuse and repair them. We also know that lots of brands and designers that it's sometimes difficult for them to know what is the best way to design more circular, more sustainable. So that's why we are also developing software tools. And one of the things which we are also doing is getting some labeling in place where we can find all the data which are relevant for getting the garments more circular. As a final, if you want to have a circular value chain, we also want to avoid unintended releases. So that's why we're also working on the minimization of microfibers inside the environment. Then the second pillar is on the bio-based one. Here, the main goal is to actually replace the current most often used materials, cotton and polyester, with more sustainable bio-based alternatives. For the cellulose, we are working with, for the cotton, we are working with cellulose, which is being made from bio-based sources, like for example, straw or seaweed. For the fossil-based polyester, we are working with bio-based polyesters, which we are tailoring to make them more suited for clothing applications. And then also all the subsequent coating, printing, dyeing, finishing steps are being developed to be bio-based. Then we have the last pillar, which is on the local aspect. And here we want to produce our garments within a network manufacturing, where we have actors from fiber to garment present in the value chain. Also, if you work locally, it's needed to work at smaller scale. And this is possible if we can cooperate with micro factories having automated production. As you can imagine, we need really people, actors active in these value chains. So that's why we're also building a community with actors spread over Europe and active and willing actually to change to a more sustainable clothing industry. So here in the next slide, you see an overview of the circular value chain which we are developing within the HereWear project, where we start from biomaterials, make yarns out of them, then fabrics, and finally make these fabrics into a garment. For the end of life, we are focusing on the repair and also helping the recycling of these garments, for example, via the labeling. Of course, as you can imagine, it is not possible by one institute, so we are cooperating with a group of very motivated partners to get this project a success. So now I'll just give a short update on where we are with the work. So the first thing which has been done by our partner UEL was to make a collection of existing and emerging bio-based materials to get a view on what is there at the moment and what still needs to be developed or improved. We also give like a time frame with it. Is it already available now, or will it only be available in the future? Further, we also had some developments on the bio-based textiles, where we produce biopolyester yarns, which have good properties to be used in the clothing industry. Also, first cellulose filaments have been produced, which were based on straw. And then also bio-based printing and dyeing is happening at the moment, of which you also see an example on the slide of the picture with the HereWear logo being printed. As I mentioned already, we really have also the aim to build a community of like-minded actors, of people, companies, institutes who are willing to support the transition to a more circular clothing industry. So that's why we are having this community being built, and it's already active. We already have quite some members in the community. And if you would want to become a member, you're really welcome to join. And you see the link here also on the slide. It will give you some access to dedicated information. You will get more into contact with other people, persons who are also interested in this topic. And you will have the opportunity to be more involved in our project activities. And then to end my presentation on the HereWear project, some take-home messages. So our material library and also our first technical activities really showed that it's possible to make these bio-based textiles with good properties to be used for garments. Also, in general, we know that if you want to make the clothing more sustainable, you really need innovation covering different disciplines. And in order to do this and to make this possible, we need partnerships over the full value chain. So this is, again, a warm invite to join our community. So thank you for your attention. And if you have any questions, happy to answer them.
Thank you very much, Lien. That was a very interesting presentation again on textiles. I do have a question from the audience for you.
Yes.
They're wondering if there's been any reactions from the fashion industry on your vision for circular fashion. specific, the move from offshore production to within Europe? Is that something that you've had a chance to discuss with them, or have been able to come up with some sort of?
Of course, it's a challenge, I would say, but we also notice that there are brands who are willing to produce more in Europe, and it's really something that they are also supporting, even though it will not be possible for all clothing, for sure not. It will be a stepwise process, but I can imagine that it will improve in future for some, I would say. So also companies will really notice that the fashion brands, they're really having sustainability, it's really important to them. It's becoming more important, and you really see that they are willing to make some changes step by step. And
from my own personal curiosity, the textiles that are coming out of this, I mean, for in the fashion industry, is the very, as I should say, very. They can be very picky about what they use and how it feels, how it looks.
Yes.
And are your products able to compete in that market, where they can be extremely picky about what they want to use and what they're not, depending on what people like or don't?
Yeah, so we are working together in the project with some designers, so we get their feedback immediately, and it's really useful for us to guide our developments, because we learn, okay, they do not like this, we should try to improve it. So it's really something that we are learning, and it's we are getting there. Of course, the project is running for 1.5 years. We are not yet there, but they do like what we can obtain, and they are also, if needed, they are adapting their design to the bio-based materials that we can produce at this moment.
Okay, thank you. We have a question from the audience from Asif, but I'm not. Yes, there you go. Asif, can you please ask a question and make it quick, because we need to go on. We can't hear you, Asif.
Can you hear me now?
Now we can.
Okay, perfect. So I have a question, like, how does a startup who wants to be aligned with your project can be benefited? How would you encourage a startup to be collaborating with your organization? Thank you.
Sorry, I could.
The question is, how would you say that is there a place for startups to engage with your project, and how would they be able to do that, and how would you recommend that they get started on that?
So it's not that we are a project giving funding to other projects or to other initiatives to do their work. So that's not what we are doing, but we do have the HereWear community, where we are getting more in contact with other partners, other companies. So I would say, please join the community. You will be get access to some dedicated information, and also maybe later on in the project we might need to couple, for example, for some larger scale trials.
Okay, thank you very much, Lien. Looking forward to hearing more about your developments in the future. We are moving on to our next project, staying within the textile industry, and it's NewCotton, which focuses on high-performance, biodegradable, regenerated NewCotton textiles using infinited fiber technology. I'm very curious to find out what that is. So please welcome Kirsi Niinimäki from Aalto University presenting.
Thank you. It's really my great pleasure to be here presenting NewCotton project. And it was also nice to hear from HereWear project, which actually is a twin project. We are getting funding from the same funding instrument. So yes, today I'm going to present NewCotton project, where we really are aiming towards these kind of industrial demonstrations. So we are basically testing technologies which earlier has been more on this kind of like a lab scale, and now we are really trying to do this industrial level demonstration, how this actually closing material loop and circular economy really happens then in the future. And our aim is to foster innovations that enable bio-based textile value chains to become more resource efficient, circular, and reduce their carbon, greenhouse gas, and water footprint, in line with climate, energy, and sustainable development goals. So of course, this is the future of textiles and fashion, that everything actually has to be or function according to circular economy principles. So I think that this is a good example that how this actually then happens in practice, and what kind of obstacles we still have to face and solve, that this is the reality in the future. There are 12 industrial players who are collaborating together to really build this kind of new kind of ecosystem to entirely circular model, to emphasize this one. And we have 2 years time to do this project. And textile waste is collected and sorted and regenerated into a new textile fiber that looks and feels like cotton. So really the starting point is the textile waste, and then we are trying to upscale it so that this is going to be high level, valuable new fibers again back to the textile and fashion industry. And we are using the Infinity Fiber Company's technology for this. And the fibers will be used to create different types of fabrics for clothing that will be designed, manufactured, and sold by global brands Adidas and H&M. So it's really important also that there are these big brands involved, that actually they are also doing their tests as well as giving feedback all the time when this tests are actually running. And the idea is that actually we are trying to show that, well, this is the reality. It's possible to use textile waste efficiently in the future. So we are also trying to be an inspiration and a stepping stone for further, even bigger circular initiatives in the industry going onwards. And this is, of course, according to the EU policy, that actually we are really trying to move textile and fashion industry towards circularity. Here are the partners. I'm going to go through them one by one. So of course, the leading partner is the Infinity Fiber Company, who owns the technology, and they will create this unique cellulose-based textile fibers out of post-consumer textile waste. And then we have Frankenhuis and Zamk, who will be working on the pre-processing and research for pre-treatment of textile waste. So of course, that's a really important part and haven't been done in this big scale beforehand. So there are a lot of this kind of new knowledge that we are gaining when we are scaling up from the lab to really industrial level processes. And then there are manufacturers, Innovafil, Textile, and Kipas, and they will use these regenerated fibers in their own processes to produce yarns, woven fabrics, and denim from this out of this material. And then there are stakeholders which are more involved on this research, Revolver Waste, RISE, and us are the university. So we will collect and provide data, conduct research and analysis, and we also have Fashion for Good, who's taking care of the dissemination and these communication activities, and H&M and Adidas, who are then really producing this capsulate collections out from this fiber. And this is the same and previous slide, but this actually shows that we are really aiming to close the loop. So there are activities, actions, stakeholders throughout the supply chain, but now actually the supply chain is circular. And of course, this brings new kind of values as well as new kind of actors in the textile value chain. And actually there's a lot of new kind of knowledges that we also have to produce so that this is possible to do in practice. Very shortly about this Infinity Fibers technology, regeneration technology. So it's cellulose-rich textile waste goes in, and they have named this fiber Infinna. It's a novel regenerative textile fiber that looks and feels like cotton. So really this kind of like a high value is the aim, that it's as good or even better than the virgin material. And now we are aiming to produce this kind of fibers that are made from 100% of post-consumer textile waste. Of course, it's possible to mix the fiber with virgin fibers too, if that is needed, but actually now we are really aiming this 100% of waste origin. And of course, the idea is that we try to substitute the use of virgin material. So this is, of course, very important from the textile industry point of view. And this material is also biodegradable and free of microplastics. and yarns and fabrics can be created on 100% from Infinna, or as mentioned already, it can be possible to blend with other kind of fibers if it's needed. And they can be recycled again. So that's the idea also, that, well, these products will be designed so that they are also possible to recycle at the end of their lifetime. And right now this technology is in the scaling phase. Very shortly about our role as at the university. So actually we are trying to observe as well as enhance the ecosystem building, what happens in this kind of ecosystem. So that's actually one of our activities in here, that we also try to produce new knowledge that actually what this means from the stakeholders, business as well as industry point of view, but we also try to influence of this EU level policy making, that how actually this kind of recycling could be then enhanced in EU policy. And we aim to build a new knowledge of circular ecosystem with the co-constructed with the partners, and this knowledge will be then used while constructing educational and training materials. So the idea that we are trying to also publish some open access online educational materials from our learnings throughout the NewCotton project. So, and where we are now, actually, we have been working now a year and a half. We still have year and a half time to go, so we are really in the middle. And there has been, let's say, some hiccups or obstacles, because something that seems to work in the lab scale might not work so well in the bigger scale. So there has been some problems as well as some delays, because there's new machineries are needed to build, especially with this pre-treatment of textile waste, for example. So actually now they are up and running. So actually it has been quite interesting to follow that this is also a totally new type of industrial sector that is actually now emerging in Europe. So, but now seems to be that the process obstacles has been solved. So the production is now waiting and soon to start. And actually companies, common companies are now designing the products. So the idea is that we have a first launch already next autumn. So capsulate collections with different types of textiles and different types of products. So that will be the first launch from this project. Adidas have done a quite large consumer study. So they wanted to know from different countries, different consumer types, that actually how ready consumers are to accept recycled products, recycled materials, and what are their expectations. So they did a quite wide study with their consumer groups. We are building the ecosystem understanding, so the first papers will come out soon, as well as we are also then moving towards this kind of like a new types of business understanding, what this ecosystem building and stakeholder collaboration actually could also enhance new types of business thinking and business understanding. So here we are. So a lot has been done and a lot still needs to be done. Thanks. That was my presentation.
Thank you, Kirsi. That was fascinating. One of the things that I was a little bit triggered by in the was you mentioned of the very wide consumer study. One of the things that we saw in one of our previous projects to do with sofas was that once you told somebody that they were sitting on a sofa made from circular products, they didn't mind so much that it wasn't quite as comfortable as the virgin material sofa. And I was wondering if you could say something about that, if any of that came out in the Adidas consumer study, that we might be able to trade in some of our comfort for our sustainability in the future.
Yes, with textile and fashion, especially in the fashion field, it's really important, this kind of like attributes that we are able to reach with this recycled textile. And of course, the idea is that we aim to be even better than this virgin cotton. So that is actually one goal in the project, that it's like a super quality product or fiber that comes out from this, so that is also valuable. I think that that's really important. This kind of comfort issues is really important. But then if you look what people are saying about in the consumer study, for example, so it's quite obvious that people in West are a little bit more well aware about these environmental problems in the fashion field. So they are more positive towards recycling, textile recycling, for example, compared to Asian countries. or developing countries, for them this might be totally new types of concept. And some people are hesitated about colors or chemicals which might stay still in the fiber, but actually those are possible to take away when we are recycling textile waste, for example. So it's even possible to clean all these kind of harmful chemicals when we are then. So it's like a pure fiber at the end of these processes. But this kind of like I think that at the end, especially fashion consumers they are thinking more about this kind of comfort or this kind of quality aspect, that where actually this fiber origins from. Is it recycled or virgin? I think that that's not so important if the quality is high enough.
Okay, well, thank you. And we have to move on now to our next project, which is Remadyl, which focuses on the removal of legacy substances from PVC through a very special extrusion process, I'm told. So to tell us all about that, we have Isabel de Schrijver from Centex Bell.
Yes, okay, this should work now. I was still muted. Hello, hi everybody, and thank you for this opportunity to present the Remadyl project. So as you have seen here in the title, we work indeed on legacy additives. With the main aim, we focus on PVC material. So why PVC? I think we have also heard it before in the CisuFlo project, where we have PVC in floorings, but PVC is still quite an important polymer and has a lot of issues when it comes to legacy substances. So there we would like to find a solution with the Remadyl project in order to increase the ratio of recycled PVC in the future. So first of all, let me focus a little bit why we focus on PVC. I already mentioned it a little bit, but if you look at the uses, it's the third most imported synthetic plastic that is being used after the polyolefins, but it has very unique properties. It is versatile, it's durable, it's easy to clean due to the fact that it also contains a chlorine atom in its molecule. It also is fire resistant, and it has a very excellent ratio of economic cost to performance. You can see here in the picture some examples where the flooring was already being considered, but it goes much broader. It's being used in the medical field, it's being used for protective materials. You see here pipes, tubics, and then also, of course, well-known window profiles that are being used. If you look at total productions, we are about 40 million tons of PVC that is being produced each year. So it also generates, of course, a lot of waste materials. So where are we today when it comes to PVC recycling? Then, of course, PVC might also here be a quite successful story, because PVC has the longest history when it comes to plastic recycling. Up till today, there are already quite some initiatives, and the picture you see here on the right bottom is a picture of one of our partners in the consortium, that's the Koning, that it has already a PVC recycling plant being installed and is already mechanical recycling a lot of waste streams. Of course, they are not the only one. There are a lot of companies that are already recycling PVC materials. You can also see that there is the Vinyl Plus initiatives. So that's an organization that focusing on the recycling of PVC, and they really put on some efforts to make as much as PVC being recycled. So mechanical recycling, I think this is already quite known. Also some chemical recycling route are being considered. But then, of course, we do have some challenges when it comes to PVC materials. When you look just at the thermoplastic nature, PVC is also a very interesting material because it can be recycled several times without losing any significant property. So that makes it also here a very interesting materials. As already mentioned, this would be a great success story, but of course we do have some challenges, and this is a very important challenge that we are trying to cope with the Remadyl project, and that's the legacy substances. When you look at old PVC materials that are coming back, and especially very old PVC materials, we have two main problems. And one of the problems is the presence of lead stabilizers that are now maybe not being used anymore, but they were used in the past. So we will find them back in PVC materials that comes back end of life. And the second important issue for the more soft PVC materials is the presence of plasticizers. So therefore, we started the Remadyl project in 2019. So it lasts until 2023. Where we will focus on the removal of those legacy substances. And I will guide you a little bit where we are today and what are solutions that we will present to you as possible ways to remove those legacy substances. First of all, a very important task is, of course, the identification of the materials, and then very specific, the identifications of the legacy additives, because you might need to trigger out those materials that does contain those legacy additives. And then we work together with the partners mentioned here, so with Iris and LEVIS, on two different methods. So the first method is, of course, the identification of the plasticizers, where, of course, we started with model samples, but we are now also looking at end-of-life PVC streams, trying to separate depending on the type of plasticizer being used, because, of course, not all plasticizers are bad. And you see here on the picture a nice example where we were able to separate a DOP plasticizer from a DPHP plasticizer. So this would help, of course, to have a first separation of your base material. Second measuring technique that we are developing is to detect the lead concentration, because lead, if you detect it, it's one aspect, but also to have an idea about the concentrations of lead being used in the materials. And there we are trying to build an inline monitoring line at the recycling plant, and we are testing different types of rigid PVC samples to be able to detect the high amounts of lead and to make sure that we are well below the REACH legislation limit that are being set up for those different materials. So that's, of course, the first step. Once we have identified the material, next step is to having a look, okay, how can we remove those legacy additives? Because the PVC is still a very interesting material. It's a very useful material to recycle, but we want to get rid of those legacy additives. And for the removal of the plasticizer, we do make use of supercritical CO2, which is being considered as a kind of green solvent, together with some anti-solvents, or co-solvents to extract the plasticizer. First of all, we did some trials on lab scale, where we played with the optimal extraction conditions, which would mean temperature, pressure, combination of the co-solvents, and of course also having a look at the impact on the PVC matrix. Now we are transferring those optimal conditions to a continuous process, where you see here in the picture below. So we will use a continuous extrusion line where the supercritical CO2 is being added to the polymer melt together with the co-solvent, and where we are trying to do the removal of those plasticizers, the extraction in line during the extrusion of the PVC materials. Next step is, instead of not only removing plasticizer, is also trying to remove the lead out of the PVC materials. And there, supercritical CO2 is, of course, one aspect, but it's not sufficient. So there we are looking at novelty solvents, which are also the green solvents, the safe solvents to work with, working with different ratios of solvents. And again, we did a lot of optimization, time, temperature, combination of certain ratio of PVC with some solvents. And you see here some pictures in the bottom of the PVC samples that were being processed, and you see some of them, they are still quite nicely white. The right one has a brownish color because there we had some degradation due to the solvent choices we made. So we ended up with a few solvents that were very useful to extract the lead out of the PVC matrix. So now we are at the upscaling phase, where we are trying to process some kilogram scales so that we can also really fully re-evaluate the polymer properties after the extraction of the lead. A second option, which is being evaluated by our partners AIM Plus and University of Valencia, is instead of using solvents to remove the lead, is to use a new kind of way of melt filtrations, where we do work with a complexing agent that will bind the lead out of the lead being present in the PVC with that complexing agent, and where we are using the filter technique to filter out the lead that's out of the PVC matrix. So the first trials were being carried out, and they are very promising to use like a classically melt filtration project on an extrusion line to filter out the lead and to complexate the lead on that filter materials. Of course, then once we are being able to extract those legacy additives out of the PVC matrix, we have some partners in the consortia, both soft and rigid processing companies that will make new materials with recycled PVC. The Koning will produce some new window profile. Pro Molding is working with injection molding, and Danossa is working with the soft PVC materials to make some very soft barrier materials with PVC. Another important aspect, of course, okay, you can remove the legacy additives, but what to do with those legacy additives? And therefore, we are investigating the possibilities to purify, first of all, the extracted lead and to reuse this extracted lead in other applications, and also to chemically modify the plasticizer that comes out of our process and trying to reshape it, modify it, and that is not again anymore a legacy component, but that we can safely reuse those plasticizers in future application. Therefore, we do not only work together with our partners in the project, with Fraunhofer and ASOR, but we also look over the project and work together with the project Circular Flooring, because they have similar issues with plasticizer, and we are trying to learn from each other projects to see how we can also deal with those legacy additives in the future. So for us, I think also those hazard aspects, hazard assessment are very important. So this brings me to the end of my presentation. I hope to have you a short introduction in the project. I'm gladly to present you all partners that do work together with us, and feel free to ask some questions or contact us later on if you have specific questions for us. Thank you very much.
Thank you very much, Isabel. I was wondering, I mean, every time that we introduce new processes to be able to enable recycling, we also talk about extra costs and extra issues. So I was wondering if you could address that and how you might be able to.
Yeah, well, that's the main reason why we are focusing on the extrusion processes, because this would mean we have a minimum impact on additional processing techniques, additional machines that needs to be involved. If you look at the filter technique, now a classically mechanical recycling plant is working with those methods. The supercritical CO2 is just an introduction into their extrusion lines. So I think, and that's the main reason why we are focusing on those techniques, to keep the additional costs as low as possible.
I do wish that luck with that.
Of course, we are still facing challenges. Indeed, times in extruders, and those are still issues we are trying to solve. But that's the main goal, of course, to do it with existing equipment, with as less as possible additional investigations and needed to make it economical feasible.
Of course, always have the lowest possible barrier.
Indeed.
To be able to use new technologies. Thank you very much. We do have to move on to our next project, though. We're circling back to the automotive sector with LEVIS, light materials for sustainable electric vehicles. And for that, we have a team of two presenting, Agustin Ciminelli and Floris Dennison.
Okay, thank you for the presentation. Please tell me if you can see properly my screen.
We can see.
Yeah, okay, good. So, good morning to you all. I'm Agustin Ciminelli. I'm the technical coordinator of the LEVIS project. On behalf of the whole consortium, it is a pleasure for us to be part of this webinar. So, basically, the content of our presentation today is this one. I will start with a brief introduction to the project. After this, Floris will share with you what we are doing in order to push forward circularity in the project, and then we will have some time for questions if it is necessary. So basically, LEVIS is a 3-year project that is focused on technologies for weight reduction for electric vehicles. The main objective of the project is to develop, verify, and demonstrate lightweight components and technologies to achieve this weight reductions in this specific type of vehicles, and applying at the same time eco-design and circular design methodologies during the whole project. So the consortium of this project is composed by 13 partners, including some research and technology centers, also industrial partners, SMEs, tier ones, and we have also one OEM within our team. The technologies on which we are working in the project are being applied to 3 different use cases or demonstrators that are basically a suspension control arm, a battery box, and a cross-car beam. You can see in the picture these specific parts. In terms of the innovations and the technologies that on which we are working in the project, well, basically the project is about multi-material solutions, looking for hybrid products combining metals with carbon fiber thermoplastics composites, putting the right material in the right place. We are also developing cost-effective and scalable manufacturing processes, and also joining or assembly processes in order to produce this type of parts, hybrid parts or components. We are working also in low-cost bio-based carbon fibers, looking for a good compromise between the mechanical properties, the weight reduction potential, and also the cost of this type of reinforcements. We are also developing design and simulation methodologies in order to obtain accurate service life predictions that allow us to get optimized designs. Another field of work in the project is about the introduction of sensing and structural health monitoring technologies that allow us to extend the service life of the products. Regarding the end of life, we have a specific work package that is about recycling and reuse routes, and particularly we are working in the bonding on demand technologies in order to facilitate the separation of parts for reuse or recycling. And finally, as I have said before, one of the key points of our project is the implementation of eco-design methodologies during the whole project towards the sustainability of our solutions. So Floris will share with you specifically what we are doing with this regard. So,
yes,
Floris.
Thank you, Augustine. Yeah, thank you. I'm the SCA specialist of the LEVIS project. So to go further on the less technical part of the project and more on the circularity approach we are implementing into the whole project. So with the first few months in what we did, we a eco-design toolkit in order to implement eco-design into the first stages of the design process. So what this entails is that we've developed a toolkit consisting of multiple different eco-design tools that are already existing in literature or in practice, and we altered them in such a way that they're easy to use for the designers of the demonstrators. So the idea is of these eco-design tools is to integrate lifecycle thinking and circular economy principles into the design process. It is especially for the first stages of the design process. So as you can see in the figure below, it's more for the product planning, research, and the designing concept. So you don't, if you do this whole eco-design toolkit, you don't get a detailed design or a final solution. It's more about the concepts and the solutions you're designing to. One of the main benefits of this eco-design toolkit we have implemented, does not solely focus on the environmental or technical part. It also takes into consideration the economic and social parts. And this is really important because this way it doesn't treat them separately, but it integrates all in a whole, and you can also assess the different KPIs, the key point identifiers, into the same eco-design toolkit. So next slide, please. Yes. Yeah, all right. So the results of the eco-design toolkit, if we look at how the partners perceived this toolkit, is that it was a success. They found feasible improvement options based, on the results of the toolkit. They got a better understanding, so knowledge was increased after using this toolkit. We did receive some feedback in making it easier to use. But because of this, they also expressed interest in using the tool for future applications. There were some difficult challenges and lessons we documented, and basically it revolved a lot around having a learning curve and trying to get up to speed with these principles. And they needed some workshops, some feedback, some explanations, examples to really properly use the eco-design toolkit. To really see the end results of the usage of the eco-design toolkit, throughout the project, we have some additional follow-up moments to see what the final effect is of using the eco-design into the first stage of the project. So more details will follow later in the upcoming years. So next slide, please. So what we're currently doing now is we're performing a lifecycle analysis. We are currently working on doing the benchmark lifecycle analysis. So the lifecycle analysis for the demonstrators with the new materials themselves will start in August. Additionally, we'll do a lifecycle costing, and we will look for further improvements and opportunities. So there are some challenges, especially in retrieving data from analysis, and these are all mostly part of having separate value chains into the market. But these are challenges that we are looking into, and we need good communication between value chains. So if this is the last part. So if there are some questions still, then we are happy to answer them. And thank you all for listening.
Thank you very much, Floris. There is a question from the audience, particularly focusing on which stakeholder or users are being targeted by these guidelines. And by that, I imagine you're targeting designers, but designers collect requirements from across the needs of the product, which has to do with business, it has to do with materials. So how do you make sure that the designers even get a chance to use these guidelines?
So the idea is that these eco-design tools are used in a collaborative way. So in this way, you have the first parts of the eco-design tools. You have to get information about the project, and you have to get the KPIs. And that way, you have to collaborate also with different members of your team, of your organization, to get to this information. So, but these are all important parts for your design process, because you need to know what you're designing for. So you have to get in contact with the financial team. You have to get in contact with the sustainability team of your project, and all to get a good understanding of why are you designing this product. And this is basically one of the first steps to perform.
But so where does the process start? Who do we have to convince to take the decision that we need to either implement these guidelines or achieve greater circularity, so that it gives the impetus to the design process to say, okay, we need more information about what we want to achieve. But who makes that decision? How do we influence that decision to actually get started?
Well, the decision, of course, mostly lies with the project management. But the thing about this toolkit is that it uses the 4 different focus areas. So the economic, technical, and sustainability, and the social expertise, and the focus areas. So the big benefit of this is that in a normal design process, you've always these different fields that are constantly striving with each other. You know, you want to make it more, technical sound or sustainable, but then you have to budget constraints. And by using this eco-design toolkit, you take it all into the one approach. So in this way, it is a sort of under construction here. So this way you can use this eco-design toolkit to implement it all with each other.
Okay, well, thank you very much. I'm sure that there will be some great things coming out of these projects. We have come to the end of the project presentation section itself, but obviously there has been a little bit of a delay. So we're starting on the roundtable discussion a little bit late. I hope that some of you can still be with us for a little bit longer, so that we can have at least some questions. If there are any specific questions that you would like to have addressed from the audience for this section, then please put them into the chat and we will make sure to ask them. To kick us off though, I would like to put some attention at least on a couple of issues that I see as systemic challenges that we have as circular projects in common. One of which, of course, is, I think, also very important for the automotive industry, but also, as was mentioned, I think, in the flooring industry, that some of the materials that we recover, it can be decades before we get them back into a recycling stage or a reuse stage. So therefore, how do we design our processes? How do we compensate for the fact that we might have to deal with materials that might no longer be legal, as maybe perhaps in the Remadyl case, or changed in such a way that they are no longer what is currently being used 10 to 20 years from now. So, for example, the average lifespan of a car is 10 to 12 years. So when we get back all of the materials from that, can we still use them? I don't know, maybe we can start with ALMA, with Rajesh. Is there something that you can say about a strategy we can use for that?
Indeed. So the first element is we need to have design for recycling already embedded within the industry, within the automotive sector. And in ALMA, for example, we are taking into consideration the product design element, which we are doing now, attached with the recyclability element. So what recycling technologies would fit into the new lightweight solutions we are developing, and whether they could be recycled or at all 15 years down the line. So that gap already exists in the industry, not only in automotive, but beyond for other sectors as well. That has to be bridged. Design for recyclability or recycling technologies, taking into consideration whether those recycling technologies will be ready commercially 15 years down the line. It's really important that the industry players look into these aspects during the product development cycle itself. And the story goes beyond ALMA. Other projects also have to consider it. And of course, the big players who put the specifications for product development, they need to take this into consideration. And some of the elements, especially the complex multi-material products, have this challenge of recyclability. And this goes beyond legacy chemicals or legacy products as well. So we really need to hit the nail here for recyclability.
For sure. From I would just like to check with Floris whether you agree with that, or do you have a particularly different perspective on how we can deal with materials coming in 10 to 20 years down the line?
Yeah, no, it's a common issue. So in case if you're designing for recyclability, you're dealing with new materials and technologies, and which are being, the end of life is 10 or 20 years from now. So those are issues, and you have to take them into account into the design process, and you have to really look forward to see what will gonna be the new technologies of the future in that case, so you can implement those knowledge, those ideas already in that case. In terms of reuse possibilities, you can also look at making it easier for the end of life industry, sort of to say, in making it more modular, making it easier to disassemble. So in that way, the possibilities for the end of life industry are also greater in that sense, to really use the materials or different materials of your components of the vehicles or different ways. In that there are more possibilities essentially in the future.
Yes, it's always good to work on possibilities for the future. I think one of the things also mentioned in perhaps, I think it was the Multicycle project, is the robustness of the process. So can we design processes that can accommodate a wide variance of either qualities and or extra additives, contaminants, to be able to separate those properly? So I was wondering if I could have maybe also the perspective from Dr. Martin Schlimmer on how do you see that? Is that a problem for the things like the creosote process, or is that something that we can easily handle?
Honestly, it is of course always a problem. Whenever you really have to adjust to real existing waste streams and to changing waste streams, it is nothing which pops up directly. So each process has to be adjusted. But this is, let's say, state of the art in all the recycling plants out there. So we are not at the very beginning. So whoever is running packaging or automotive recycling right now, or electronics recycling, they also have to deal with changes in the feedstock since 10, 20 years. So this is not stopping from one day to the other. So it is a slow process. So that means in the end, whenever you have invested such a plant, you need to do further investigations of your feedstock. You probably have to adjust even at that scale later on. So this is, let's say, a part of the game, probably not too problematic in the end. What I don't like from all these discussions is if we say we first have to have a design right now, and then we have to be ready with recycling in 10 years. That's too late. If we see in all the industries that they go away from materials that are not recyclable, and they don't see any clue or any light at the end of the tunnel that it will work, they just go out of these materials. And for me, that really means in terms of materials, not in types of how to design these materials into composites and so on. We need to have a toolkit of what are, let's say, the typical polymers in each of these waste streams. So in automotive, there will be polyamides, there will be polypropylenes, there will be probably some ABSs and so on. So if that's true, then we can focus on these polymers and try to get them out of current waste streams, and things will be better in 10 years, of course, since then recyclability will be increased. But we cannot just start in 10 years. We cannot just focus on what we produce right now. We should start with what we have. And even then, if that doesn't work too good, then let's start with industrial waste, since whatever we produce right now will be waste in 10 years. So we can start directly with industrial waste in smaller scale and upgrade. And then we are ready for end-of-life waste in 10 years. So this might be another strategy. But with Creosoft technology and solvent-based technologies, we have at least the advantage of high purification. So if there's a difference in composition of waste streams, or some legacy additives pop up or become legacy additives in 5 years, we have the chance to increase purification in these plants. And this is, let's say, from my perspective, the added value of this solvent-based technology.
Thank you. I think that's we must be prepared for the future already. Ina, from the DECOAT perspective, does that mean that you see also the triggerable debonding as one of those strategies for the future that is also maybe future-proof?
I think so too. Of course, within DECOAT, we really focus now on the technical aspects. I think we also have to see it broader than that, because I don't think it will come to real industrial implementation if it only comes from certain players. So you really have to have the whole value chain aligned. You really have to, at a certain point, involve the recyclers and so on. So it's a whole process. Also, the sorting needs to be installed. So it will not come from a single player. I think it's for all the technologies, you really have to have the whole value chain aligned there. So I think it's a quite complicated project, but we already see quite some interest from the industry already for these technologies. We are contacted very often by companies who see a lot of potential in the techniques. And also their first idea is to try to implement it, for example, on post-industrial waste. As they say, for example, if we have some objects which are wrongly painted, then we can remove the paint and use that object again internally, so that they would like to use that already internally. So I think that's the easiest step here. And then, of course, later on, this technology will only be at end of life of these products. So it's not something that you can implement tomorrow. So it's a long-term vision, but we see some nice potentials. Like for the Resco technology has already been implemented in niche markets. Like, for example, they use it in aviation to remove the paints from the planes and then repaint. So it's already there, but it's, of course, a huge step from aviation to more commodity products later on. But when it's feasible already there, it should also be feasible for other products in the long run, in my vision. But
Yes.
It needs research, cooperation, and things like that.
Of course, cooperation is always going to be the key, and as you say, involving the whole value chain in the discussions and in how we're going to deal with future scenarios. We're very much running out of time, but I did want to be able to at least address one more issue, I think, which is prevalent more perhaps in the fashion industry, but I think it's a design challenge in and of itself, which is, of course, that one of the tenets of circularity is life extension. But we can design the products to be physically last longer. But will people still want to use them? Will still people want to use fashion designed 5 years ago or drive in a car that was created 15 years ago? So maybe you could say something about that, Kirsi?
Yes, that's actually quite important. A quite important issue, because of course we can produce higher quality and longer lasting products, but will consumers change their own consumption habits? That's a big question, because there are a lot of this kind of like an emotional side when we are buying some stuff, trendy stuff, and fashion is not only clothing. There are different kind of areas that fashion is touching so drastically currently. So yes, that's a really important issue. But I think that for EU legislation, for example, there's possibilities to even drive towards this kind of higher quality. Actually, in textile sector, we are talking about this label, quality labels, for example, and also that what are those kind of minimal lifetimes, and would it be possible to somehow inform that to the consumers, as well as expecting producers to also provide repair services to extend the use time, for example. So actually that is a quite hot discussion going on in EU policy level currently, that how we can actually try to hit against this fast fashion and fast fashion consumption especially. So that's a risk than when we are talking about the circular economy, so that we are not only focusing on this textile waste recycling, that actually we also have to really tackle also this topic, how to extend the product lifetime.
Thank you. Perhaps Lee.
Sorry, just one small comment. I think we have to extend life, but it's not needed that it is with one user. So you can extend life if it has multiple users. The second-hand clothing, second-hand cars, it's also possible, and I think we also need to encourage the second-hand users to increase the use life, let's say.
That is another option. That is a very good point that you make there. From your own working group there, do you actually address the topic of design itself, as in how maybe we should design clothes to be longer lasting in or more classical look, or in maybe a more neutral? I don't know how you would design something that people would want to use for the next 10 years rather than just for the next fashion cycle.
Yes, actually, we are dealing quite a lot of this kind of fashion consumption side and what to do with that. And as Lien was already pointing out, this kind of alternative business models actually are one option, that they could be possible to recycle, for example, or second-hand fashion, for example, or this kind of leasing or renting, or this kind of repair services actually. So those kind of issues are quite important, and seems also be that actually quite many companies are interesting to test out or experiment, especially with the second-hand fashion. Seems to be quite trendy, even that big brands actually are taking that as a part of their business model. So I think that there's in that sense, there's interesting times for us to wait. And we have been collaborating quite a lot with Finnish textile and fashion industry, and they are working a lot with quality, for example. So they are really aiming for the best quality, but then they are not so well of informing that to the consumers, that why the price tag is higher than with the competing brands, for example. So this is also something that how to inform these issues towards the consumers.
Maybe I can also give a small
comment.
What they also have seen is, for example, if you can personalize your clothing, if you can put, for example, your own print on something or things like that, that the consumer has a tendency to hold that piece of garment for much longer. So that it's not that it's something that it's really your own material. Of course, it will not be feasible for all the clothing and all the things, but it can also help to extend lifetimes. That's something that came across some time ago, and it's an interesting approach also.
Indeed. Anything that we can do to help at least delay the moment of the end of life is always useful. We're running out, as I said before, we're running out of time, and we're also running out of listeners at the moment. I think they're all heading out to lunch at the moment. So unfortunately, I'm going to have to draw it to a close here. I think it was a very good webinar. I think we've been able to learn lots about the different projects. And I certainly wish we could continue this discussion further. We can't do that right now, but we will make sure that we have other opportunities to bring the projects together and discuss more in detail how we can all collaborate and work together to resolve some of these more systemic issues. So I would like to thank all of our presenters. I would also like to thank once again the European Commission for making all of this possible. And I would like to definitely thank all of the people watching and listening to us today for their attention. I would like to inform them that we will be sharing the video and of course the presentations that you have seen today. We will email you with how you can and get your hands on those a little bit later on. And apart from that, I would just like to wish you all a great day and hopefully see you soon.